In this video, we're going to be focusing on calculations on sum to infinity of a geometric progression. Let's start with this question. Question number 1. The first and the sixth terms of a geometric progression GP are 8 and 1/4 respectively. What is its sum to infinity? So let's start by writing solution. And then from the information we have that the first term of this GP is equals to 8. So the first term A is equals to 8, and then the sixth term is equals to 1/4. So sixth term, we're going to denote it by T sub 6 is equals to, we have A r raised to the power 6 minus 1 is equals to 5. Now this system is equals to 1/4. And then A from the question is equals to 8. Have 8 multiplied by r raised to the power 5. Now let's multiply both sides by 1/8, so that we have 1 times 1 is 1 divided by 8 times 4 is 32. Then this is equals to, this 8 and this 8 to cancel, we'll be left with r raised to the power 5. Now we know that 32 is equals to 2 raised to the power 5. So we write 1/2 raised to the power 5 equals to r raised to the power 5. Okay. And we know that 1 raised to the power 5 is also equals to 1. So we're going to have that 1/2 raised to the power 5 is equals to r raised to the power 5. So that when the exponents are equal, we equals the basis. So we're going to say that r is equals to 1/2. So this is the common ratio to this question. And then to find the sum to infinity, we use this formula, that sum to infinity is equals to A divided by 1 minus r. So this is equals to A is 8, then divided by 1 minus r is half. Then this is equals to 8 divided by 1 minus half is equals to half. Now let's multiply both the numerator and the denominator by 2 to clear the fraction at the denominator. So if you do that, this 2 and this 2 will cancel, we'll be left with 8 times 2. So we have that the sum to infinity is equals to 8 times 2 is 16. And so 16 is the answer to this question. And the option is option D. Question number 2. Find the sum to infinity of the following series: 3, 2, 4/3, 8/9, 16/7, and so on. So we're going to write solution. And then the formula for sum to infinity is given by A divided by 1 minus r. Then from the question, the first term A is given as 3. Then let's find the common ratio. So the common ratio is second term divided by the first term. So r is equals to 2/3. So let's substitute A and r into this equation. So I have that sum to infinity is equals to A is 3, then divided by 1 minus r is equals to 2/3. So I have 2/3. So this is equals to 3 divided by, now 1 is the same thing as 3/3. So 1 is the same thing as 3/3. Then minus, we have 2/3. So this is equals to, we have 3 minus 2 is equals to 1. So this is same thing as 1/3. So we have 3 divided by 1/3. Now to clear the fraction at the denominator, let's multiply both the denominator and the numerator by 3. So we're going to have this, and this one will cancel. We have 3 times 3 is equals to 9. So we have that the sum to infinity is equals to 9, which corresponds to option D.